And today let us solve a sum on the Fourier series. So, for the expression f of x equal to pi minus x by 2 ranging from 0 to 2 pi, we have to obtain the Fourier series and also deduce the given expression. So let us start off with the basic Fourier equation. The basic Fourier equation is f of x is equal to a0 by 2 plus sigma from n is equal to 1 to infinity a of n cos nx plus bn sin nx. For satisfying this equation, we need to find a0, an and bn and then substitute it in this equation. So for finding a0, the formula is a0 is equal to 1 by pi integral 0 to 2 pi f of x dx. And for finding an, it is 1 by pi integral 0 to 2 pi f of x cos nx into dx. Now for finding bn, the formula is 1 by pi integral 0 to 2 pi f of x sin nx dx. So now let us start off with finding a0. Let us substitute f of x, which is pi minus x by 2 in the given equation for finding a0. So a0 will be equal to 1 by pi integral 0 to 2 pi pi minus x by 2 dx. So now let us take out this 2 because it is since it is a constant, and it will become 1 by 2 pi. And integral of pi is pi into x minus integral of x is x squared by 2. For solving these sums, you have to know basic integration. And now the limits are from 0 to 2 pi. Now let us substitute the limits in this expression. It is 1 by 2 pi, and when you substitute 2 pi in place of x here, it will become 2 into pi square, and minus when you substitute 2 pi in place of x square, it will become 4 pi square divided by 2, that is nothing but minus 2 pi square. And when you substitute 0 in place of both the x's, it is 0, so it is minus 0, and 2 pi square minus 2 pi square is 0. So our a0 now it is 0. Similarly, let us find an. So for finding an, we have to substitute f of x in this formula. So an is 1 by pi integral 0 to 2 pi pi minus x by 2 into cos nx dx. Now to solve this equation, we can't use any simple integration formula. Because there are two polynomials, we apply the Bernoulli's rule. I hope you remember the Bernoulli's rule. Please go check it in the previous video if not. So, by applying the Bernoulli's rule, it is 1 by pi. Now the first term is pi minus x by 2 into integral of the second term. The second term was cos nx, and integral of cos nx is sin nx divided by n. This divided by n is due to the chain rule. Please go through all the basics of integration, then only you'll be able to solve this. Minus differentiation of this term, that is minus 1 into the integration of this term, that is integration of sin nx is minus cos nx divided by n because this is already there, and by chain rule again into n, so it will be minus cos nx divided by n square. A correction, this is integration of differentiation of pi minus x by 2 is minus half. Because pi by 2 is a constant, it becomes 0 differentiation, and differentiation of minus x by 2 will be minus 1 by 2. Now going to the next step, we have to substitute 2 pi in place of x first, that is like upper limit term minus the lower limit, and then we'll minus the whole thing and we'll substitute x equal to 0. Now when we substitute x equal to 2 pi and x equal to 0, this total term becomes 0, because sine of 2 and pi is 0. You can go check the previous video, and sine 0 is 0, as you all know. So now this term totally becomes 0. We need not substitute in the next step. Let us go to this. Now we take out 2 outside, that becomes minus 1 by 2 pi n square. Because here there are 3 minus signs. Minus into minus is plus. Plus into minus is again minus. And you take out, this is pi, you take out 2n square. So that will be minus 1 by 2 pi n square. And the limits for cos nx. And now the remaining part is cos nx. The limits are from 0 to 2 pi. Now this will be minus 1 by 2 pi n square in the brackets cos of 2 pi into n minus cos 0. When you substitute 2 pi and 0 as the values of x, that is upper limit value minus the lower limit, this becomes 0 because cos of 2 pi n is 1 and cos of 0 is 1. 1 minus 1 is 0. So any term into 0 becomes 0. So our an term also becomes 0. Now to find bn, we have to substitute the value of f of x in this formula. That will be bn is equal to 1 by pi integral 0 to 2 pi f of x, that is pi minus x by 2 into sine nx dx. Now this also we're going to solve by the Bernoulli's principle. That is, this is u into integral of v, that is v is sine nx, minus differentiation of this into again the integral of the previous integral. So let's go through it. Now we take out 2 because it's a constant, that will become 1 by 2 pi integral pi minus x, that is into integral of pi minus x into integral of sine nx. Sine nx integral will be minus cos nx by n. Now minus differentiation of pi minus x. Differentiation of pi is 0. And what is differentiation of minus x? That is minus 1 into the integration of this term. Integration of just cos nx is sine nx by n into minus 1 by n will give you minus sine nx by n square. And the limits are from 0 to 2 pi. So now the bn will be equal to, here similarly like the previously what we did, sine nx, this term due to sine nx it becomes 0, as sine of 2 pi n and sine 0 is 0. So we neglect this term and we substitute 2 pi and 0 only in this term. So we have our first term, because the second term contains sine nx, and since x will be 2 pi and 0, the answer would be 0. Now when we substitute 2 pi here, pi minus 2 pi gives us minus pi into cos n of 2 pi minus pi into cos 0. We know that cos of 2n pi and cos 0 is 1. That will become minus pi, that is minus 2 pi. So that will be, and minus into minus is plus. So that will be 2 pi divided by 2 pi n. 2 pi and 2 pi gets cancelled. So we get our bn is equal to 1 by n. Now finally we substitute all the values which we have got, that is a0, an and bn, in this formula to get the Fourier series. Since a0 and an is 0, the first two terms are 0 and bn is 1 by n. So our f of x will be pi minus x is by 2 is equal to 0 plus 0 plus sigma n is equal to 1 to infinity sine nx. This is our Fourier series, but according to the question, we have to derive an expression given. The expression given is this. Now to derive this, we have to pick up a value of x, which when we put it in the Fourier series, gives us this expression. Now, if we put x as 0 or 2 pi, it will be sine 0. Sine 0 is 0. So, that will not serve the purpose. So, if we take x as pi by 2, we will get the Fourier series required. Now, when we substitute x equal to pi by 2, that is pi minus x by 2, that is pi minus pi by 2 by 2 is equal to sigma n is equal to 1 to infinity 1 by n sine n into x. Here x is pi by 2. Sine n into pi by 2. Now pi minus pi by 2. What is it? It is pi by 2 divided by 2 is equal to sigma n is equal to 1 to infinity 1 by n sine of n pi by 2. Now pi by 2 becomes pi by 4. And this we write the same thing down. Now for getting the series or deducing the series which has been given in the question, let us substitute the value of n as 1 first. Now if n is equal to 1, it will be 1 by 1 sine of pi by 2. Sine pi by 2 is 1. Plus when n is equal to 2, it will be 1 by 2 sine 2 pi by 2, that is sine pi. And if n is 3, it will be sine 3 pi by 2 divided by 3. And if it's 4, it will be sine 4 pi by 2 by 4 and so on. Now what is sine of pi by 2? That is 1. And what is sine pi? Sine pi is 0. So this term becomes 0. What is sine 3 pi by 2? That is minus 1. So that will become minus 1 by 3 and so on. Hence you deduce the given equation. Here you go. This is how we solve a regular Fourier series expression. First we find the values of a0, an and bn and then substitute in the Fourier equation, that is the Euler's equation. And if you're supposed to deduce any expression from that, we try the values of x which can give us the possible expression. Usually if it is x, if the term contains sin x, you usually will not apply x equal to 0 or 2 pi because the term will tend to go to 0 and you will not get the expression. But whereas if the term contains a cos term, that time you can use x is equal to 0 or 2 pi because cos 0 is 1. So it depends on what kind of expression you're supposed to derive. Based on that, you assume the value of x and get the desired equation. Thank you. For more such videos, please like, comment and subscribe.